Welcome to the law of cosines video. So this video is going to walk you through how to use the law of cosines. Starting out kind of the same way with law of sines, I'm going to label my triangle just to make sure that I know what each side is in my triangle. So across from angle A is little a, across from angle C is little c, and across from angle B is little b. Now I want to notice the difference here between what we just did with law of sines and what we're going to do with law of cosines. Because with law of sines, we always had an angle and the side across from that angle. And what you're going to notice here is I kind of highlight each of these pieces of information. I've got angle A, but I don't know little a. I do know side C, but I don't know angle C. And then I have little b, but I don't know what angle B is. So I don't have one complete ratio if I were to try to set up law of sines, and that's going to cause a problem because what I have is three fractions that I know one part of each fraction, and I can't set up a ratio with that information. So we have to then rely on the law of cosines as a way to solve this triangle because once again we're dealing with something that is not a right triangle. So I'm going to write the law of cosines, and I'm going to write the three ways that you might see the law of cosines written. So that you can manage to rewrite these in any form that you want. But what we're really doing is we're saying take any side in your triangle. So let's say A, square it. And then what you're going to see on the other side of the equal sign is the other two sides that are not on the left side. So the other two sides of your triangle, B and C, squared and added together, just like you would see in the Pythagorean theorem. But then we're going to subtract from that 2 times those two sides again, times the cosine of whatever the side on the other side of the equation is. So just to kind of show you what that looks like, right? This and this are the two pieces that are across from each other in the triangle, okay? And then you'll notice we have B, B, and then C and C on the same side. So we can write this a couple of other ways. I could write this in terms of b squared. So I could say b squared equals, and then the other two sides of the triangle are on the right side, times the cosine of capital B. Once again, angle B and little b are across from each other in the triangle, so they're across from each other in the equation as well. And then there's a third way I can write this, and that's in terms of angle C. And I would have a squared plus b squared minus 2ab times the cosine of angle C. And again, I can show how this angle, angle C and little c are across from each other in the triangle, and they're also across from each other in the equation. Okay, so that's our law of cosines. Now the question is, which form of this do you use? Well, you look at the angle that you know something about, right? And that's going to be the angle that you see we take the cosine of. So in this case, we know angle A. That means we're going to use this first form of the law of cosines, all right? So we know that little a, we don't know little a, right? So little a is unknown. But we do know little b and little c. So little b is 12. So I would say a squared equals 12 squared plus, and then c is 9. So that's 9 squared. And then minus 2 times b times c times the cosine of angle A, which we know is 75 degrees. Now, what you're going to notice is that we know everything on the right side of this equation, right? This is just one big, long calculation. So I can actually type that into my calculator, and I don't really have to worry about, doing this in multiple steps. I can literally type this all in as one step. 12 squared plus 9 squared minus 2 times 12 times 9 times the cosine of 75, and I should be able to get a squared. So go ahead and pause the video here, type all that into your calculator, come back and see what you get. So what you end up with is a squared equals 169.095. I guess that would be 0.0951 if I were rounding properly here. Now that's what a squared is. So to find a, then obviously I need to take the square root of that, and you're going to get something just a little over 13. So I'm going to write a is approximately, we'll just say 13.0 if we're going to round to the nearest tenth. Now we have A, right? So in my triangle, if I know what A is, I should be able to now use the law of sines. So to find all the missing pieces that are remaining, I'm going to resort to the law of sines. And just to show you what the equation would be, I would have the sine of 75 over A equals, and then I'd have to pick one of the two angles left to find. I always try to find the larger angle if I can, so I'm going to find angle B since it's across from the larger side. So I would say sine of angle B over 12, and then do just what we did in the previous video to find this angle. Now, once you find that angle, you don't have to use another law of sines, right? So you're going to get an angle measure. You know two angles in your triangle, just subtract from 180, and you'll get your third angle. If you want to know what those are, go ahead and pause the video, try it, and come back, and you can check your answers. So if you look on the right-hand side here, I've got A is about 13 miles, B is about 63 degrees, and then C is about 42 degrees. Now that's if we're using law of cosines to find a side in the triangle. Let's look at what happens when we're finding an angle. So once again, I want to label my sides just so they match up with my angles. So I have little b is 12, little a is 13, and little c is 9. And I like to color code them. You don't have to necessarily do this, but it might help you when you're first starting these problems to at least have, the things that match up together colored in the same fashion. Now here's one where we have three sides of a triangle, but we don't know any angle. So what I'm going to do is I'm going to try to find the largest angle first. All right, so we know from our geometry by the triangle inequality that the largest angle is going to be across from the largest side. So we find our largest side, which is little a, and that means that angle A will be our largest angle. So I'm going to start by finding angle A. All right, so my focus is on A, which means I have to use the form of law of sines that has little a by itself so that I can have big A on the other side of the equation. Okay? So I'm using angle A as my focal point in this triangle, which means I have to have little a on the left side by itself. Now let's fill in what we know. This time I know little a is 13, so I have 13 squared. I know little b is 12, so 12 squared, plus little c, which is 9 squared, and then minus 2 times b times c, times the cosine, whoops, I know what C is, it's 9, times the cosine of A. Now, I do not know A, right? This is my unknown. And this is where you have to really pay attention to order of operations, okay? We have three terms on the right-hand side of that equation. This is term 1, this is term 2, and then this whole thing is term 3. So you really have to be careful about your order of operations. So let's start by doing our exponents here. So 13 squared is 169 equals 12 squared, which is 144, plus 9 squared, which is 81. Now I'm also going to do my multiplication. So I'm going to multiply 2 times 12 times 19, or times 9, sorry, and I will get 216. So what I have is minus 216 times the cosine of A. Remember what we're solving for, right? We're solving for A. I eventually want to get this all by itself. But in order to do that, sort of an intermediate step is I'm going to have to get cosine of A on one side of the equation by itself. So using our order of operations, and you can do this a bunch of different ways, but the general idea is the same. I'm going to start by adding the 144 and the 81 together. If I add 144 and 81, I'm going to get 225. Okay, minus 216 cosine of A. Remembering that my goal is to get, right now I'm trying to get cosine of A by itself. Okay, next up, let's subtract the 225 from both sides, because that is how we would solve an equation. We start by, if we're trying to get something by itself, we start by getting rid of any addition and subtraction before we try and get rid of any multiplication and division that might be happening. So I'm going to get 169 minus 225 on the left side gives me negative 56 equals, and then I just have negative 216 times the cosine of A. Now we're getting closer, right? Now I've almost got cosine of A by itself. But one more thing I'm going to have to do before I can get cosine of A by itself is divide both sides by negative 216. So now I'm just going to leave this as 56 over 216. I'm not going to worry about simplifying that because I'm going to be using my calculator in just a second. Because now I know that I'm finding an angle, so to undo cosine, I'm going to have to do the inverse cosine. So I know I have to do that to both sides. So I'm going to do the inverse cosine on the left side, and I'm going to do the inverse cosine on the right side. And the reason I do that is because the inverse cosine will undo the cosine, leaving me with just A equals whatever the inverse cosine of 56 over 216 is. And that's when you're going to have to use your calculator. I don't know anybody that can do that one in their head. But you get, so it looks like, we'll say about 75 degrees. All right, so we have A is about 75 degrees. Now, that's the first angle in our triangle. We still have to find the other two. I highly recommend that you do not try to find the second angle using law of cosines. Law of sines is a much simpler way to do that. And just so you can see, you would just set up sine of 75 degrees over 13, since you know both angle A and little a, equals, and then again, find the second side, or find the second angle. I'm going to go ahead and find angle B. So I would say sine of angle B over 12. And then at that point, you should be able to just solve that equation using the skills that we did in the law of sines video. If you need some help with that, go back and watch that video again. But you're going to get that angle B should be right around 63 degrees. So we're going to call angle B is approximately 63 degrees. So now we have two of the three angles in our triangle. To find the third angle, just subtract from 180, and you're going to get 42 degrees, and then you've got all of the missing pieces in that triangle. Finding an angle with law of cosines is the most challenging of all of those different types of problems. Hopefully this helps. Please ask me some questions if you have any, and good luck.